So I just wanted to really quickly go through another example problem of Hess's law, just to go with the last video, because I know the last video specifically talked about heats of formation, and I wanted to show you an example where the heats of formation isn't necessary because you've been provided with a little more information. So taking a look at this problem here, they want you to calculate the delta H value for this given reaction on the top between ammonia, oxygen to make nitrogen monoxide and water, and then you know certain delta H's. So I just want to go through really quickly how to isolate what you want to do and how to manipulate these reactions to get the thing you're looking for. So in looking at this, I just want to kind of take stock. What we have here is an NO, and what we have here is an NO. And I don't really see that NO anywhere else in any of the other reactants, this nitrogen monoxide. So I know that that's going to be, to figure out the delta H for this, I'm going to label these delta H's with 1, 2, and 3 so I can talk about them. I know that delta H1 is going to supply me with the information for the nitrogen monoxide. Similarly, I see that there's a water only associated with reaction 3, and that there's only an ammonia associated with reaction 2. So all I want to do is I want to change these to be in the right place and with the right number. And then if I add things up, it should kind of work out on its own. So first thing to do is I think delta H1, I think this first reaction, I'm going to need to multiply it by 2 to make sure I have 4 NOs. So we're going to have 2N2 plus 2O2 yields 4NO. And this delta H, we're going to call it 4, just I'm going to keep numbering sequentially, should be double this, so negative 361 kilojoules. Secondly, let's use reaction 2 here. I see that I have 2 ammonias as a product, but I need 4 ammonias as a reactant. So I'm going to flip the second reaction, and I'm going to double it. So this should give me 4NH3 yields 2N2 plus 6H2. So for this reaction, since I'm flipping and doubling it, delta H5 is going to be the negative and twice delta H2. So we're going to make it positive 180, what is it? Double that, 1836, 3.6 kilojoules. And then using for the waters here, I see I have 2 waters in reaction 3 and I need 6 in the product. So it's on the right side, but I need 6 waters. And so that I'm going to just basically triple the third reaction. And if I triple it, well then I triple the number. So it's going to be 14. I need a calculator because math is hard. 483.6 times 3, 1450.8. So negative 1450.8 kilojoules. So now, because I've set things up kind of nicely for myself, if I just add up the reaction, delta H7 is going to be the sum of numbers 4 through 6, sorry. And what that gives me is, for delta H values, negative 1628.2 kilojoules. And for the reaction, we're just going to add up everything. So I've got 2N2 plus 2O2 plus 4NH3 plus 6H2 plus 3O2. Excuse me. Yields 4NO plus 2N2 plus 6H2 plus 6H2O. This is a really big equation. It's got a lot of chemicals in it, but all we have to do really quickly is I want to go through and I just want to cross out anything that shows up on both sides. So I see 2N2s here. Oops. I see 2N2s here, and I see 2N2s here. Excuse me. 3O2s here. Oh, I don't want to do that. Sorry. The 3O2s are fine. Here I see 6. I see 6 H2s here, and I see 6H2s here. So once we remove all of the substances that are redundant, show up on both sides of the equation, I'm just going to erase them really quick, and I want to see what we're left with. If we look, after going through this process, what we're left with is 4NH3. You can add the 3O2 and the 2O2 to make 5 oxygens, yields 4NO plus 6H2O, which is exactly the reaction that we want to have made. By going through this process of finding products or finding substances that only show up in one reaction, you can kind of start to think about how you manipulate reactions to build any reaction you want to take a look at. Thanks for watching.